First thing we're going to look at is problems 1 through 9, direct and inverse variation. So direct variation, there's a few forms of direct variation, and it's been a minute since we did this. This was a part of 7.1. And the main form we had was y is equal to a times x. Well, we could also say it's the same thing as x is equal to a times y. A is just a number. A is representing a number. Any number. Now, there were two other forms that we had. Y over x is equal to a, or really we can say x over y is equal to a. We didn't really talk too much about x over y, but it's really not that much different from y over x. All we did was just flip the x and y. But any of these four here are direct variation. So if we have an equation that shows up in one of these four, it'd be direct. Now, inverse variation, the main form that we had, was y is equal to a over x. Now, the other form that we had or could have is x is equal to a over y. All we did was just flip the x and y values. And the last way that we could have an inverse variation equation, or way it could look, is x times y is equal to a. All these are just different ways that we could write an equation as direct or inverse variation. So it might be helpful to write those down. Because now all we have to do to figure out if the equation is direct or inverse variation or neither is match them up. So if we look at number 1, 8y equals x. Is that going to be direct, inverse, or neither? It would be direct. It actually matches up to our x is equal to a times y. A in our case is just 8. If we look at number 2, x times y is equal to 1/5. Would be inverse. Because it's our x times y equals a. A in our case is 1/5. Let's look at number 3. 6x plus 4y equals 7. Neither. With direct and inverse variation, we're not going to have addition or subtraction. Interestingly enough, we also need two variables. We need x and y. So y equals 7 is not going to be either. It's neither, because we need x and y. We need two variables. Number 4, 6 over x equals y would be inverse. Number 5 would be inverse also. And neither. Really, neither is going to be easy to spot because it's either going to have addition or subtraction or only one variable. Because if there's only one variable in the entire equation, it's going to be neither. Questions on 1 through 6? So if you don't have those general forms for direct and inverse variation, I'd make sure to have those down, because that's going to make these a lot nicer to work with. We're ready for the next set. 7 through 9 aren't going to show up on the test. Ten through 13, simplify. Whenever we're simplifying any of these here, we need to factor. We need to factor the numerator and denominator, the top and bottom of this fraction as far as it'll possibly go. So we look at number 10, 2x squared. Well, that's as factored as it gets. The main reason we know that is as simplified as it gets is because there's exactly one term, one single term. Can't simplify any further than that. On bottom, we have 3x squared minus 4x. Yes, whenever we're factoring, we look for a greatest common factor first. We need to look for the greatest common factor between the two terms, which is indeed x. 3x squared and 4x do have a common factor of x. which we can factor out. And if we factor an x out of 3x squared, we have 3x. And if we factor an x out of 4x, we get 4. Now what's left inside the parentheses is 3x minus 4. There is no other greatest common factor, nothing in common with 3x and 4. And the degree is 1. The biggest exponent attached to the variable is 1, so that is actually simple. Now we just need to see if there's something in common on top and bottom. The x outside. And we can simplify 1x on top and bottom. On top, the 2x squared is going to become 2x. On bottom, the x will simplify out, leaving us with our 3x minus 4. Now, since the x was outside the parentheses and being multiplied with our 3x minus 4, that's why we can simplify it and the x squared on top. But the 3x and 2x won't simplify because the 3x minus 4 on bottom locks those two together. That as far as that goes. Questions on this here? And for this here, except for the two problems where you're solving and there are restrictions, we're not going to be focusing on the restrictions for these here. Questions on number 10 before we look at number 11. Number 11. We need to factor the top and bottom of this fraction. Now, the top of the fraction, 32x squared minus 50, is their greatest common factor? 2. If we factor 2 out of 32x squared, we get 16x squared. Minus, if we factor 2 out of 50, we get 25. Now, factoring the 2 out does give us something that's kind of nice, because 16x squared minus 25 is a difference of perfect squares. Because we do have two terms being subtracted. What times itself is 16? 4, so we'd have 4x and 4x. What times itself is 25? So we do have 5 and 5. Now, there's nothing that says I specifically have to factor the bottom first, or factor the bottom next. Because so far, have we done anything to the bottom of this fraction? Well, no. I do need to factor it. So under this first one, we could have our factors and work with this here. Or I can focus purely on the top still. Because we said that 16x squared minus 25 is a difference of perfect squares. So our signs would be opposite. Factors of 16x squared would be 4x and 4x. 25 would be 5 and 5. Because there's nothing saying that we can't just keep factoring it down, even though I haven't done anything or written anything in the bottom yet. We can come back to it. But sometimes it would be nicer to work with that top, get it factored as far as we can, especially if we do see the factors are 4x plus 5, 4x minus 5. Does that make sense? Okay. And part of the reason I emphasize this is because if something's going to cancel on top and bottom, one of the two factors on bottoms has to be what? 4x plus 5 or 4x minus 5, yes? We saw those, we could factor that a little bit nicer. If we look at the denominator, 4x squared minus 17x plus 15. Since the third term is positive, the signs are the same and match the sign in the middle term. So we have negative and negative. That gives us a little more information. It means the 4x plus 5 on top is not going to match with anything on bottom, because both the denominators are minus. So the best we can hope for is a 4x minus 5 on top and bottom. Now the factors of 4x squared, our factors of x squared are going to be x and x. Now the factors of 4 are 1 and 4 or 2 and 2. So we look at this here, 1 and 4, 2 and 2. It's going to be 1 and 4. Because the only way that we can match up anything on top and bottom is having 4. And this is part of the reason why factoring the top all the way down was nice, because probably our first instinct wasn't going to be 1 and 4, it was probably going to be 2 and 2. So it gives us an idea that 4 and 1 is going to be the better option so that we get something to match up with our 4x minus 5. Now the factors of 15 are 1 and 15 or 3 and 5. And again, if we want something to match up, it'll probably be helpful to use the 5 and 3 to give us 4x minus 5 and x minus 3. Now, even if we don't see that or notice that, that's fine, because again, our factoring steps are still going to work. We're still going to get there. But if we can get one of them factored as simplified as possible, it kind of does help in our other case. Questions on how we factored this here? So what's in common on top and bottom? 4x minus 5 and 4x minus 5. And what that leaves us with is 2 times 4x plus 5 over x minus 3. And again, like with most of this chapter, factoring is going to be the key point to all of this here. Questions on any of this so far? Get ready for the next one. Now we're going to skip number 12, not because of anything about it is harder or not as hard as any other part. There's just not going to be a sum or difference of 2 cubes. You're not going to have to factor a sum or difference of 2 cubes on the test. So I'd rather focus on some of the other problems than on that one there. 13. X squared minus 4x minus 12 over x squared minus 4. Again, I would say factor whatever you can see or find the factors of easier first, because it'll make the rest of it work a little bit nicer. X squared minus 4 is a difference of perfect squares, which is indeed going to factor to x plus 2 and x minus 2. Yes. So it'd be very tempting to want to remove the x squared and x squared, yes? And I think that's where you're going with removing what we can find in common. But the x squared minus 4 is stuck together. The x squared minus our 4x minus 12 is one term. So unfortunately, we can't just cross them out. Because with multiplication, the reason that it works nice is because we can really split these apart. I'm going to go back to the previous one. Because even this here, 2x squared, align that. I could set on top x times 2x. Because when we multiply x times 2x, we get 2x squared. Now, plus, there's no good way to do this with addition, because really we'd be saying x squared plus x squared to get 2x squared. And if we add, the denominators have to be the same. Here they would simplify, but we're not going to actually get to something we want. It works out the same. But with multiplication, because we could say x times 2x on top, x times 3x minus 4, and this x and x will simplify out to 1. Because really that's what we're doing with the multiplication. Because once we get it into a multiplied form, we can split the parts that simplify to 1 off to one side, keep what we have left. Is why it works with multiplication and not so much with addition and subtraction. Now, when we look at the top, x squared minus 4x minus 12, we need to factor it. Since the third term is negative, the signs are opposite. One's going to be positive, one's going to be negative. Factors of x squared are x and x. Now, our factors of 12 are 1 and 12, 2 and 6, 3 and 4. 2 and 6. Because if we want something to simplify, we either need an x plus 2 or x minus 2 on top. The only way we can get that is with the factors of 2 and 6. Where do we want to put the 2? Where do we want to put the 6? 2 with the plus, 6 with the minus. And we can check this to make sure. X times negative 6 be negative 6x. 2 times x is plus 2x, giving us a middle term of negative 4x. And again, this step is more just to make sure we have the correct set of factors more than actually part of one of our steps. It's just to check and make sure we factored it correctly. Now at this point here, what's in common on top and bottom? An x plus 2, which leaves us with x minus 6 over x minus 2. Because with our terms being multiplied, we could just split that apart, say x plus 2 over x plus 2. Anything divided by itself is 1. And what we have left is x minus 6 over x minus 2. That's as simplified as it gets. Questions on 13? 10, 11, or 13? And most of the simplifying is going to be more about factoring and then canceling out common factors on top and bottom than anything else. Now, I'm not going to focus too much on 14, these monomial, where we have a single term in all 4 spots, where both the numerators are monomials, 1 term, both the denominators are 1 term. Because all of our problems are going to look more like 15, where we have these polynomial terms on top and bottom. Now, 15 does have an individual 2x term, that's fine. But all 4 spots aren't going to be just a single term like in 14. And the first thing we need to do on this here with these here, with multiplication problems, is factor all 4 spots. Factor all 4 spots down as far as we can possibly go. Now 2x is as factored as it gets because it's a single term. There's actually another one that's already factored. X minus 1. X minus 1 does not have a greatest common factor between x and 1 besides 1. And the degree is 1, x. If it had been x squared minus 1, we could factor it to x plus 1, x minus 1. We can do more with it. X minus 1 is as simplified as it gets. So we can look at the numerators. Top left or top right? Which one do we want to factor first? X squared minus 4x. Is there a greatest common factor between these two terms? X. If we factor the x out of x squared, we get x. If we factor the x out of 4x, we get 4. Inside the parentheses, the degree is now 1. There's no other greatest common factor. It's simplified as it gets. That leaves us with x squared plus 3x minus 4. There is no greatest common factor. Kind of one of the big giveaways, especially with these polynomials. X squared, does it have a number in front of it? No. Is there a number without x? Yes. No greatest common factor. Now the third term is negative, so our signs are opposite. Only factors of x squared that we have are x and x. Factors of 4 are 1 and 4 or 2 and 2. Which one do we want to try first? 1 and 4, because if we do 1 and 4, there's a chance that we could have an x minus 1 match up on top and bottom. And we can check and make sure x times negative 1 is negative x. 4 times x is plus 4x, giving us the positive 3x middle term we wanted. So again, this is part of the reason I would highly suggest factoring the ones that you can see the factors up first, because it gives us an idea, top and bottom hints at what we could have. Now at this point here, we do need to multiply everything together. On bottom, we have 2x times x minus 1. There's not a whole lot of reason to actually multiply through, because for us to be able to simplify, we need it in a factored form. On top, we have x times x minus 4 times x plus 4 times our x minus 1. What's in common on top and bottom? X minus 1. Anything else? The x. Because the x's are outside the parentheses, they're being multiplied with everything. There's nothing that's adding with the 2x or the x by itself on top. We can simplify those out. Or another way to say it is I can move this out and just say that we have x times our x minus 1 over our x times x minus 1, which is being multiplied with our x minus 4, x plus 4 over 2 is really what we're saying, is because that's the nice thing with multiplication. I can just split those up because those are the same. We can move them around. This is 1, leaving us with x plus 4 times x minus 4 over 2. That's the nice thing with multiplication, is that x times x minus 1 times our x plus 4 times x minus 4, we can split them apart, put them back together. Addition and subtraction is not as nice with doing that. Questions on this here? Yeah, so what I wrote in some purple off to the side is just side explanation of why this works nicely with multiplication. If everything canceled out, what would it have been? 1. If everything simplifies out, it's just 1. Let's look at 16. X squared plus 3x minus 4 over x squared plus 4x plus 4 times 2x squared plus 4x over x squared minus 4x plus 3. Fortunately, we don't have a difference of perfect squares in any of the 4 spots. So where do y'all want to start? Top right, 2x squared plus 4x. Is their greatest common factor? 2x. And if we factor a 2x, all right guys, focus in. Out of 2x squared plus 4x, we get 2x times x plus 2. So far we know if something's going to simplify with the 2x times x plus 2, we either need a 2x or a term out front, or x plus 2. Probably the x plus 2. Well, we can go on and factor the denominator. X squared minus 4x plus 3. Third term's positive, so the signs are the same and match the sign of the middle term. Negative and negative. Factors of x squared are x and x. Factors of 3. 1 and 3. And incidentally, those are indeed the correct factors. If we check, we'd have negative 3x minus x, which is indeed negative 4x. Where do we want to go next? Top or bottom? Top, x squared plus 3x minus 4. Since the third term is negative, our signs are opposite. Factors of x squared are x and x. Factors of 4, we have 2, 1 and 4, or 2 and 2. Which one do we want to try first, 1 and 4 or 2 and 2? Yes. 1 and 4. 1 and 4 is probably going to work out nicer, because if we use that there, we can match up an x minus 1 with an x minus 1, and hopefully that will simplify out. If we do check this here, we would have negative x plus 4x, which is positive 3x, the middle term we wanted. Makes sense? So that is nice. Last one, x squared plus 4x plus 4. There is no greatest common factor between these three terms. Our third term is positive, so the signs are the same, and they do match the sign of the middle term. Factors of x squared are x and x. Factors of 4 are 1 and 4, or which one do we want to try first? 2 and 2. And the reason we lean towards 2 and 2 is 2 and 2 does give us an x plus 2, which do match on top and bottom. And incidentally, they are the correct middle terms. It does give us the middle term. Questions on this here? Now again, at this point we could rewrite the whole thing again, but we know, and we've seen with multiplication, especially once it's in factored form, we're really just putting the parentheses next to each other. And at this point, our x minus 1 and x minus 1 will cancel. Our x plus 2 and x plus 2 will cancel. Now, since there was only one x plus 2 on top, it's only going to cancel with the one on bottom. And this is going to leave us with 2x times x plus 4 over x plus 2 times x minus 3. Questions on this here? All right. Let's look at 17. X squared minus x minus 12 over x squared minus 16 times our x squared plus 2x minus 8. So x squared minus 16 does factor nicely. It's a difference of perfect squares. We have x plus 4 and x minus 4. Now we can factor the numerator of this first, x squared minus x minus 12. There is no greatest common factor between these three terms. Our term's negative, so our signs are opposite. Only factors of x squared are x and x. Now our factors of 12 are 1 and 12, 6, 3, and 4. 3, 4. Which one do we want positive? Which one do we want negative? 3 positive and the 4 negative, because at this point we could have x plus 4, x minus 4 match up. Now the middle term we want to be negative x. And if we check this here, x times negative 4 would give us negative 4x. 3 times x would be positive 3x. And our negative 4x plus 3x would give us the negative x, middle term we wanted. So we know for sure the x minus 4 and x minus 4 will cancel. So when we look at the other one, since it doesn't have a denominator, it is understood to be 1. So our x squared plus 2x minus 8. 2 sets of parentheses with 3 spaces. Since the third term is negative, our signs are indeed opposite. Only factors of x squared are x and x. Now our factors of 8 are 1 and 8, or 2 and 4. So we can try 2 and 4 first. Yes? Which one positive, which one negative? 4 positive and the 2 negative, because we still have an x plus 4 that could cancel out on top and bottom. And incidentally, if we check this again, x times negative 2 would be negative 2x. 4 times x would be positive 4x, giving us the positive 2x middle term that we wanted. And when we multiply these here, we'll see that the x minus 4 and x minus 4 here will cancel. X plus 4 and x plus 4 will cancel, leaving us with x plus 3 times x minus 2 over 1. So when we're dividing by 1, we don't have to write it. But if 1 ends up on top, we do have to include it. If you're not sure, go on and leave it there. Because having this over 1 is not wrong. Questions on 17? So I'm not going to look at 18. There's not one like 18. Because they're going to look more like the last two we did in 19. We're going to have monomial, these binomial, trinomial terms, these multi-terms. Now with division, the first thing we do is we keep the first rational expression the same. We change it from division to multiplication, and we flip the second term. Keep, change, flip. And from here, this is the exact same as multiplication. Really, for division of these rational expressions, keep, change, flip, treat it exactly like we did with multiplication. So the next step is to factor. Well, we don't have a difference of perfect squares, so we just have to pick a spot and go. So I'm going to start with x squared minus 3x minus 40. Since the third term is negative, our signs will indeed be opposite. Our factors of x squared are x and x. Now the factors of 40 are 1 and 40, 2 and 20, 4 and 10, 5 and 8. And the set of factors of 40 that we're going to want are 5 and 8. X plus 5 and x minus 8. And we could check that we would get negative 8x plus 5x would give us our negative 3x. On the bottom, x squared plus 8x minus 20. Third term's negative, so our signs are going to be opposite. Factors of x squared are x and x. Now our factors of 20 are 1 and 20, 2 and 10, 4 and 5. Here we're going to want 10 and 2. And if we check this here, x times negative 2 would be negative 2x. 8 times x would be positive, or 10 times x would be positive 10x. Negative 2x plus 10x would give us our positive 8x. Now we have the last two to factor. So x squared plus 12x plus 20. Since the third term's positive, our signs are the same. Match the sign of the middle term. So plus and plus. Factors of x squared are going to be x and x. And the factors of 20 that we want are going to be 2 and 10, because this will give us a common factor on top and bottom of x plus 10. On bottom, x squared plus 13x plus 40. Third term's positive, so the signs are the same, and they do match the sign of the middle term, so plus and plus. Factors of x squared are x and x, and we'll want 5 and 8. Our like terms on top and bottom would be our x plus 10, x plus 10, x plus 5, x plus 5. As much as it, or as nice as it would be to be able to cancel the rest out, our x minus 8 and x plus 8 are not like terms. Our x plus 2 and x minus 2 are not like terms. And there's no way for us to get them to be like terms. Questions on this here? We will finish this up tomorrow.